Namaste, hello and welcome to PM E-Vidya channel number 9. My name is Tanvi Khurana and this is a science session for class 9th students. All of you're watching this channel and we are going to talk about greenhouse effect. What is greenhouse effect? And what are its causes, how is it related to us at all? That's what we are going to discuss in this session. If you have any questions, you can mail us on our email ID, which is ciet.kishormunch@gmail.com. You're watching us live on our YouTube channel, NCERT Official. In the live chat box, you can write your questions, we'll receive them, and our expert, she'll be more than happy to answer all your queries, all your questions related to greenhouse effect. Let's meet our expert for this session. We have with us Dr. C.V. Shimre. Welcome, ma'am.
Thank you.
Ma'am is from Department of Education in Science and Mathematics, NCERT. And without wasting any more time, let's begin this discussion. Ma'am, to begin with, greenhouse effect. Can you define it?
Okay. Before we get into the definition, I'll just explain to you a little bit about what we're going to talk in this session. So as you can see in the slide there, if we can go to the slide. So greenhouse effect is something which students are very familiar with. In fact, everybody is so familiar with greenhouse effect now because it's becoming a very common word, commonly used word. And so, but there's also a lot of confusion about greenhouse effect. So what we're going to try to do in this session is explain to you what greenhouse effect, so that you understand what exactly it is, the science part of that, as well as we're going to talk a little bit about what is the connection between greenhouse effect and the global warming. And another very important aspect of this is climate change, because people tend to equate greenhouse effect or global warming with climate change. So are they really different, or are they the same thing? So these are some of the things that we're going to try to explain in this session and try to understand in this session, right? So yes, before I get into the greenhouse effect as such, let me take you to a slide which tells a little bit about the fundamental processes in the ecosystem, because greenhouse effect happens outside, I mean in nature. So it's important for us to understand how this ecosystem, how nature works in reality. So if we look at ecosystem, students are again very familiar with the word ecosystem. They have studied ecosystem in geography, they have studied this in science also. So this is not a new term. But to remind them, so as they all know, ecosystem is a system where biotic and abiotic factors interact. Biotic means the living things, and the abiotic means the non-living things. So these two components, these two factors, they interact and they form a system. And this system goes on and on unless it is disturbed. So it's a natural system, it's a self-sustaining system if it is not disturbed. So how does an ecosystem function? Basically, there are two processes which are fundamental processes, which we call ecosystem processes also, which are the nutrient cycle and the energy flow. Nutrient cycle consists of those biogeochemical cycles. For example, the movement of nutrients in an ecosystem. How, for example, carbon moves, how, example, nitrogen moves in an ecosystem, how phosphorus moves in the form of a cycle. That means that they don't remain at one place, but sometimes they're in the atmosphere, sometimes they're in the living organisms, sometimes they're in the soil. So, but the cycle goes on. So that's part of the nutrient cycle. There is another process that always go on in the ecosystem, that is energy flow, which starts with the sun, the energy from the sun. Then it energizes the producers, the plants which produce food, and so then from the producers to the consumers. So this energy is transferred from one trophic level to the next. So these are the two system, basic system, fundamental system which runs the ecosystem. Because of this two system that is going on simultaneously, because of which ecosystem is able to function, it is able to sustain itself. So now let's come to closer to the greenhouse effect. So again, before we get into the greenhouse effect, it is important for us to understand this carbon cycle, which is one of those biogeochemical cycles. As students can see in that table or in that picture, it's a carbon cycle as it is labeled there at the top right corner. So they can see there carbon dioxide in the atmosphere. So from there it goes to the organic compounds, that is the plants. As students know, plants photosynthesize. For that, they require carbon dioxide. They use carbon dioxide to produce food for themselves as well as food for other organisms which feed on them. Then from there, as they can see all kinds of arrows coming out. Some of those arrows are going back to the atmosphere. Some of those arrows are coming to the organic compounds, to the animals. That means that animals are feeding on the plants, because of which now the carbon that is present in the plants are now transferred into the animals. Then they can also see some other arrows, for example, the arrows which indicate coal and which indicate petroleum. So from the plants, it goes to the coal. It forms millions of years it takes to form coal. So coal, although it is abiotic as such, it starts from living organisms. That is the biotic factors. That is from plants. Then you have again another product, petroleum, which is again formed from living organism. So it takes millions and millions of years to convert itself into petroleum. So these are the two products which we are exploiting in a big way right now by using this petroleum and coal. And in the same time, we are exploiting and we are polluting the environment. Then they can also see the arrow coming out from the atmosphere. It goes to the carbonates in water. A lot of carbon gets into the water, in the oceans. So we say that oceans are a good carbon sink. That's the reason. Then some of those carbonates, they also get into the limestones. So that is one aspect of that. Then there is another aspect of that. Inorganic carbonates in the shells of living organisms, which you find in oceans and all. In their shells, you find this some form of carbon in that. Then ultimately what happens is that from atmosphere, it goes to plants, it goes to animals, it goes to soil, it turns into petroleum, it goes into shells, and it goes to different things. But then ultimately what happens is that it goes back to the atmosphere. When we respire, when plants respire, when animals respire, this carbon in some form, it goes back to the atmosphere again. And so this cycle continues. So this is a cycle, because it goes from the atmosphere to the organisms, then back to the, this cycle continues, and it's like the amount that remains in each place is almost constant. It's not constant, but it's almost like, because it's cycling. So but then there is no disturbance as such unless we intervene. So that's what is happening in nature. This is what is naturally happening. But what we have done with it is, we know that now we talk a lot about greenhouse effect. That's the reason we're talking about this right now. And so what is happening right now is that we have disturbed that natural cycle. So the natural cycle is disturbed in the sense that more carbon is in the atmosphere in the form of carbon dioxide. So all those carbon which were present in the form of coal and petroleum, now they are in the atmosphere. So that carbon in the form of carbon dioxide is in the atmosphere, because of which you can see the proportions now changing. So we have disturbed the natural cycle of carbon. And
when you say we
yes,
as in
human beings, human beings, because we are the only ones who can exploit because of our intelligence, so-called intelligence, So we have been exploiting all this, applying our minds for our own benefit, our short-term benefit. If you look at the long-term benefit, which is not at all beneficial, but we are very short-sighted people. We want everything fast, we want everything quick, we want to have everything as soon as possible and as much as possible.
Without thinking of the consequences.
Yes. So that is the reason. So if we were using it meticulously, judiciously, then we will not be disturbing the natural cycle so much. But now that because of our greed, because of the exploitation that happens in the atmosphere, in the environment, so more and more carbon dioxide, or more and more carbon in the form of carbon dioxide, is being pumped into the atmosphere. And so what's happening? So as I said, we have disturbed the carbon cycle. And other gases that's besides carbon dioxide that is present in the atmosphere is because of human intervention again, anthropogenic intervention, which we call. Methane is another gas. Water vapor is also another greenhouse gas. Chlorofluorocarbon, CFC, students are very familiar with the short form of this chlorofluorocarbons, that is CFCs. CFCs, if they're not familiar with it, where they're used, they might remember that these were used as refrigerants, and that's the reason they can see R11, R12 and R1115. So that represents that they are refrigerants. They were used in for refrigeration in ACs and all that, to cool, you know, as a coolant. So those are some of the examples which are no more used now. So we have replaced those CFCs with right now hydrochlorofluorocarbons. Again, where do you find them? If students are aware about this, they might want to go back and see, if they own an AC, they might want to go back and see what kind of refrigerant is being used in that AC, whether it's R22 or R32 or things like that, you know. So those numbers do not just mean anything. It says a lot, because this R22, for example, is less harmful than those CFC R11 or R12 or R115. And right now, more popular ones are hydrofluorocarbons, HFCs, such as R32 and R410A. Most of the new ACs, they will have this as a refrigerant. R32 is what they're going to have. Most of the 5-star ACs, they will have this. So students might, you know, this is how we can change our lifestyle. I mean, we can be careful when we might need AC because it's hot, but we might want to choose the right AC so that we are not polluting the environment so much.
Absolutely.
We're definitely going to pollute. Whatever you use, it's still going to be polluted. We are still going to contribute towards pollution. But if we choose the right, you know, the right machine, the right device which uses less harmful, I'm using the term less harmful because everything is causing some form of pollution in the atmosphere, in the environment. Comparatively lesser. So you choose for that, and that's how we can at least cater to some of the needs of the taking care of environment. So those are some of the gases that's also present in the atmosphere which is causing greenhouse effect.
Okay.
So first of all, we are disturbing the cycle, because of which more of carbon is there, and because of human intervention through different technologies that we use in our daily life. So we are pumping more of those carbon in the form of carbon dioxide, methane, and all those gases in the atmosphere again. So all those things are causing greenhouse effect. Another important aspect, deforestation, because now deforestation means you have less plants, less trees. Less trees means less carbon dioxide, less trees to absorb those carbon dioxide that's present in the atmosphere. So now, since you don't have so much trees, now you're going to have more of carbon dioxide in the atmosphere, right? So those are the some of the reasons why there are so much of these greenhouse gases in the atmosphere. So before we are coming closer and closer to defining what greenhouse effect is, but we are not coming yet. So we have just understood what are the gases which is contributing to greenhouse effect. So before we get into greenhouse effect definition again, it's important for us to understand the electromagnetic spectrum. For example, visible light. When we say sunlight that comes from us, that's a visible light. Right. Then you have the, as you can see in the picture there, after the visible light, the longer wavelength are the infrared red radiations. So these two are very important. So in order to understand greenhouse effect, students need to understand this visible light, which have shorter wavelength, whereas the infrared radiation which have longer wavelength. So that should that's to introduce them an idea about these radiations. This will help them understanding how greenhouse effect is actually happening. Okay. Again, just to give them an idea about where is all of these greenhouse gases in the atmosphere. So as they can see in the right hand, that bar that goes up straight, troposphere is in the lowest part of the atmosphere, then stratosphere, then mesosphere, then thermosphere, exosphere. But most of this greenhouse effect happens at the upper part of the troposphere and lower part of stratosphere, I would say. But most of which in the upper part of the troposphere. So that's where you find all of this greenhouse in the atmosphere.
Okay.
Now let's come to the real greenhouse effect. So what we have discussed about the greenhouse gases that is contributing to greenhouse effect. So what are those, how things are happening in nature? So if they can see that slide, that it starts with the sun, solar energy.
Yeah.
Some solar radiation is reflected by the earth and the atmosphere. That's the first bar, number one, as they can see in the picture. That means that the solar radiation that's coming to the earth, some of it are absorbed, some of it are reflected back to the atmosphere, as it is very clear in the picture.
Yeah.
Point number two, most radiation is absorbed by the earth's surface and warms it. So whatever was absorbed, now it warms the earth. because solar radiation, as we said, some of it is absorbed, some of it is reflected back. So those which were absorbed, now this solar radiation that was absorbed, now it warms the earth. Third point, on the right hand side, right bottom, infrared radiation is emitted by the earth's surface. So now solar radiation is absorbed. Solar radiation that was coming from the sun, those are visible light. But now after absorption, when we say infrared radiation is emitted, as in point number 3, that means that it has now a longer wavelength, right? As I showed you in the previous slide, that infrared radiation have longer wavelength, whereas the visible light have shorter wavelength. So now whatever radiation was absorbed, now it also, the earth releases some of those in the form of infrared radiation, as it is written in point number 3. Then now what's happening in point number 4? Some of those infrared radiation passes through the atmosphere. Some, they're absorbed and re-emitted in all directions by the greenhouse gas molecules. So what's happening is, now the infrared radiation that is released by the earth, they're slowly released by the earth. What's happening is some of it, it passes through the atmosphere and it goes back to the atmosphere slowly. But the greenhouse gases that is present in the atmosphere, most of the infrared radiation that is released by the earth, it is now absorbed by those greenhouse gases and it is re-radiated back towards the earth. Some of it, of course, it goes back towards outwardly also, but most of it comes back towards the earth, right? So that means that radiation that was supposed to go outward is now most of which are coming back.
So that's
because
harmful.
Because of the greenhouse gases which are present in the atmosphere. So those infrared radiations that were released by the earth, they were supposed to just go straight away if there were no greenhouse gases, right? But now you have so much of greenhouse gases, so some of it of course escaped through those greenhouse gases in between that, but most of those infrared radiations are now absorbed by the greenhouse gases. For example, those CFCs, methane, you have the carbon dioxide, you have nitrous oxide, and even water vapor, you know. So all those greenhouse gases now absorb the infrared radiation and releases them back towards the earth. That means the heat which was supposed to go outside is now coming back towards the earth, and that is causing all the warming, right? Because the heat that was supposed to go out is now being re-radiated back towards the earth by the greenhouse gases, right? So that's all it says about greenhouse effect. That means that solar radiations falls onto the earth, some of which are reflected back from the atmosphere, from the earth's surface, and some of which are absorbed by the earth. Those which are absorbed by the earth, again slowly they are released, re-radiated back in the form of infrared radiation. Those released infrared radiations are absorbed by the greenhouse gases that are in the atmosphere, which again re-radiates back towards the earth.
So that's why we're facing the climate change.
That's why we are facing the warming. We are not coming yet to climate change. I'll come to that.
Okay.
So because the heat that was supposed to go back, it is coming back to us, and that is increasing the temperature on this on the earth. So that is what is greenhouse effect.
Okay.
That is, there is warming because there is excess of greenhouse gases in the atmosphere now. So let me explain more clearly in another slide. This will tell them clearly about how exactly those molecules are moving from where to here. So on the left hand side, if they can see there is solar radiation passes through clear atmosphere. So we are just trying to divide the atmosphere into two. Of course, it's not divided as such for convenience. For example, they can see in that picture, which is not very clear unfortunately, but then on the left hand side of the picture, it is pre-industrial age. That means prior around 1750s, where industrialization started, you know.
Yeah.
So that represents the left hand side. As you can see, there are less molecules of those, you know, carbon dioxide. You can see less of those carbon dioxide there, even in the picture there. But if you look at the right half, you can see a lot of those carbon dioxide, nitrous oxide, and methane in there.
Yeah.
Right? So that represents the present. So the left hand side, where you find less of those carbon dioxide and greenhouse gases, that represents the past,
Right.
where we have not industrialized so much, where industrialization has not taken place so much, because of which there are less greenhouse gas in the atmosphere. So what's happening is, when there is less greenhouse gas in the atmosphere, solar radiation straight away comes and it goes back. You know, it is absorbed, some of which are absorbed, it is radiated back, and it goes back slowly. So there is not so much of warming happening on the surface of the earth. But if you look at the right hand side, there are so many those greenhouse gases, as you can see, all congested there, pushing each other there. So when this earth surface re-radiates those solar radiation in the form of infrared radiation, these gases, now greenhouse gases, do not allow those gases to pass through them. Instead, they absorb those gases, those radiation, solar radiation. The greenhouse gases absorb the solar radiation, and they radiate those back towards the surface of the earth, as it is indicated in some of the arrows in the picture. And so that is the reason that there is warming on the surface of the earth, and that warming is increasing at the present. On the left hand side, in the past, since there was less of greenhouse gas, there was not so much warming. But now at the present that we are living in, this happened like mostly after the 1900s. So it is increasing, and there is no end to it, where it's going on increasing and increasing. There is no going back now. So as you can see, there are more and more of those greenhouse gases in the atmosphere, and that is the reason that there is more and more warming happening on the surface of the earth. So that kind of explains the greenhouse effect. The other one was in the form of solar radiation I showed. This one is clearer, I would say, where you can see the greenhouse gases represented as well, right?
Pretty much clear.
Yes.
Ma'am, greenhouse effect, that's the term. Why do we call it that?
Yes, now we have defined, we have tried to understand what greenhouse effect is, how it happens. So now, why did we even call greenhouse effect to this effect, to this phenomena, right? So that's something that's very interesting again. So I have this picture for students. Students might have seen something like this. It might not be exactly the same, some in the form of a shorter version or a bigger version or a smaller version or a more square version, whatever it is. But students definitely have seen some houses like this, made of plastic or made of glasses, right? So these are called greenhouses because green plants are grown inside these houses. It is not because it is green, and that is the reason it is called greenhouse, but green plants are grown inside that is the reason it is called greenhouse. And why they are grown inside the greenhouses, as you know, in colder places, it's really cold, you cannot grow anything outside, right? But in this kind of house, what you can do is, you can grow plants. And how that happens is, so sunlight will fall, whether it's cold or hot, anyway sunlight is going to come. So it receives sunlight, solar radiation falls into this kinds of house, which is made up of maybe plastic or glasses. So sunlight falls into that, it passes through the glass or the plastic, it gets into the house, inside the house. Now
it makes it warm.
It makes it warm because now sunlight has passed through it, but when it goes back, the glasses or the plastic, it blocks, it cannot easily escape. The solar radiation that has got into the house cannot escape easily. It can enter easily because, again, you know, the visible light, it can enter easily, but when it is re-radiated back from the surface of whatever there is inside the greenhouse, so all the re-radiated radiation is in the form of infrared, and because of which it cannot pass through this glass house or the plastic house easily, and that is the reason inside it is getting warmer, and so you can grow plants. Solar radiation enters, whatever is going back cannot get back the way it came in. So that's how it happens, you know.
So ma'am, you said we'll come to climate change.
Yes,
let's come to climate change now.
So let's quickly take this. So we talk about so much of warming. So how much warming is happening right now? So can you guess? Okay, we have shown the slide anyway. So it's like, you know, it's just 1 degree that we are talking about, but this 1 degree is making so much of changes in the whole system, how ecosystem is functioning, how biodiversity is being affected, how our lifestyle is being affected, how much we need ACs because of this just 1 degree increase in the temperature, global average temperature, you know. So although it is 1 degree, the impact is so much. That's the reason we are also concerned. Now the attempt is that we want to not to increase this further as much as possible. 2 degrees is what we are aiming for. If possible, we want to come down to this increased. We don't want to go beyond 1.5 degrees of increase. Before that, we want to take all kinds of precautionary measures. Okay, so coming back to that question, since now we said we have understood greenhouse effect, we have understood how greenhouse effect is causing global warming. Yeah, right. So now climate change. So let me just take them to this definition straight away, since we don't have so much time. So they can see that this definition. So what is this global warming? So global warming, it's the
it refers to the
long-term trend of a rising average global temperature.
Right.
Whereas climate change refers to the changes in the global climate which results from the increasing average global temperature. But climate change is not just increase in temperature. Climate change also includes all other impacts that is happening because of increase in temperature. Because if it was just increase in temperature, we could just manage somehow, you know. If it was just increase of temperature, you can buy AC, you can manage like that. But the increase in temperature is affecting everything else. It is affecting the atmosphere, it is affecting the rainfall, it is affecting the reproduction of different animals also, because so many animals are very sensitive, so many plants are sensitive to slight changes in the temperature, you know, because of that. And so when we say climate change, it is a larger impact of that average increase in average global temperature that is changing everything else. For example, as I showed you in the slide, changes in precipitation. Precipitation can be rain, snow, and any form of those, you know, water in different forms. Increased prevalence of drought, heat waves, extreme weather events, cyclones. We are seeing these cyclones, more severe cyclones, more frequently. It's not that it was not happening, but now it is happening more frequently and more severely. That's what we are experiencing. So when we say climate change, it is more about the impact that it has because of the increase in global average temperature. So when you say global warming, it's just about the increase in temperature. But when you say climate change, you also talk about everything else that is affected because of global warming. So I think we need to take some of these questions, which is very important for students to understand. So is greenhouse effect of global warming good or bad? This is something. What do you say?
It's definitely bad.
It is definitely bad if it is too much.
Yeah.
But you know, without global warming, the earth would be a ball of ice. Okay. If there was no global warming at all, if there was no greenhouse effect at all, then the earth will be so cold, nothing will exist. It will be a solid ball of ice, you know. So you need a little bit of global warming, but not to this extent.
So we'll experience the ice age again?
That is a natural cycle that happens. So that when we talk about climate change, we can talk about that. So I plan to do that in the next session. But for now, we're going to stick with this global warming and just the definition. So one more question maybe. So now global warming is good to some extent, but to the extent that we are going right now, which is very harmful, and it is keeping all of us in danger. Our life itself is in danger. So if carbon dioxide is a plant nutrient, as students know, plants utilize carbon dioxide to prepare food. Then why do we have so much problems? More carbon dioxide should be good, right? No. Because plants use carbon dioxide to manufacture food for the consumers, for themselves, as well as for animals.
Right.
Then why do we say that carbon dioxide is bad? It should be good.
It shouldn't be.
How? If there is no carbon dioxide, how will plants prepare food?
They can't. They need it.
They need it. So they don't need it so much because plant can consume so much. You know, it's not that you have so much and so plants are going to eat more and more. It doesn't work that way. So they need what they need, and so even if you provide them in excess, that's not going to help. And so you don't want excess of carbon dioxide in the atmosphere, but you definitely want some carbon dioxide in the atmosphere, which you have in the natural cycle if you do not disturb it. Another question which is very important is global warming same as climate change, which I just explained it to students.
Right.
Yeah, and students also have heard about, it was really cold last winter. How can there be global warming or climate change? Or it was not so hot this summer. How can there be global warming? These are, some silly statements that people make and assume and draw conclusion about climate change. But they need to be very careful. When we talk about climate change, it is about the long-term effect. It is not just one season. If that is happening continuously, regularly over time, maybe for 15, 20, 30 years, then you would say that climate change has happened, things have really changed. But just because last year it was not so hot or it was not so cold do not mean anything. It has nothing to do with climate change, right?
Right. So now that students have seen these questions, maybe they'll answer them and they'll share it with us. So please, now that you have seen the questions, try and answer these questions, because ma'am has explained the whole process so far, and rest of the questions we'll take in the next session. You can even call us with all the answers on our toll-free numbers. The numbers are 1800-112199 and 1800-111-265. We always wait for your answers, for your questions as well. Stay with us, don't go anywhere, because we are wrapping up this session, but we are coming back with another session. It's going to be a Hindi session and the topic will be Geet Ageet, Ramdhari Singh Dinkar. So stay with us. Thank you so much, ma'am, for joining us today.
Thank you.
Thank you to all of you as well. Please take care of yourself and keep on watching NCRT's online resource material. Namaste.